All right, in today's video, we're going to finish section 1 of chapter 4. So I just want to recap where we are. These 4.1 guided notes, we're going to start here. So make sure you still have those 4.1 guided notes open or out. And secondly, we're going to do this calculating correlation by hand guided notes. So you want to have both of these documents open for today's section as we're going to cover both of them. So starting with our second half of the lesson right now, straight line relationships. So like I said yesterday with form, or last class with form, linear is what we're focusing on because we can use what's called correlation. We said association, correlation, to describe the direction and strength of a straight line relationship between two quantitative variables. So this is a new variable. It's called lowercase r. It is called correlation. It is a number that gives you the direction and strength of a straight line relationship. Correlation is strong if the points lie close to a straight line. We talked about strength last time. It is difficult to judge correlation by just looking. So today we add a number to go with it. And that will be our correlation. It is the strength of the straight line relationship, letter R. It has a crazy formula that I'm going to show you, you know a lot about. So we have our correlation is going to be equal to, and now these are things we've seen before. X bar we've seen as the mean of a data set. SX we've seen as the standard deviation of a data set. Well, just think of it now that we have two quantitative data variables. We have a y variable. So we have y bar for the mean of the y's, sy for the standard deviation of the y's. N is always in this class been sample size. How many people are in the sample is our N. It's our sample size. We are going to use our formula to calculate standard deviation and standard deviation, mean, and then eventually get our correlation. So we need to know some facts about correlation. What is this number that's going to be the strength of our straight line relationship? These are very important notes to know what correlation is. So first, how does correlation tell us the direction? Correlation tells us the direction because a correlation in R value can be positive or it can be negative. So if the number is positive, then the direction of the association is positive. If the number is negative, the direction of the association is negative. How big can the number be? It can be as small as 0. 0 means no correlation at all. It can be as high as 1, meaning perfect linear correlation, or -1, which is also perfect linear correlation, but negative. So any 0 is the worst. 0 is the worst. And in any direction, negative or positive, further from 0, the better. So what does that mean? It means 0.7 and -0.7, they would be the same because the number itself is the strength, and in the negative in front just means negative direction. It doesn't say, so -0.5 is not worse than +0.5 with correlation. It just means negative direction. Both of them are a 0.5. So -1 to 1 is only values of R. They can only be in that scale. Correlation R does not change when you change the unit of measure. So if I go from inches to feet, R would be the same because R only measures how good do the points make a line. And if you change all of the points from inches to feet, they'll make the same line. Correlation ignores distinction between explanatory and response variables. So if I put something on the x-axis but you put it on the y, no problemo. Correlation will be the same. Correlation only measures strength of straight line relationships. So remember, the form must be linear in order to use R. Correlation is strongly affected by outliers, so always keep that in mind. If you have an outlier, it'll really mess with your value of R. So we're going to do an activity now. So I'm going to leave the slideshow. Okay, the activity will be what we handle now. We're going to do an activity and it was that second, it was that second worksheet on the module. So on the module, we saw we had 4.1 part 2, correlation, calculating it by hand, right there. That's what you're going to open, and it's going to come to right here. Let's see what we're going to do. Okay. So that word, Archaeopteryx, is an extinct beast having feathers like a bird, but teeth like a long bone and a long bony tail like a reptile. Only 6 fossil specimens are known. Because the fossils differ greatly in size, some scientists think that they are different species rather than just one species. We will examine the data and length in centimeters of a femur bone, that's in the hip, and a humerus bone, another a bone in the upper arm. And we will look at these 5 fossils and see if we think we can determine if they are from the same species or not. So first, we are going to make a scatter plot with our data. We are going to make a scatter plot for this data. So follow along with me on your copy. Our x variable is going to be the femur. So in order to do this, you should label that this will be our femur, F-E-M-U-R. This is going to be our humerus, H-U-M-R-A-S. Now, our x values go from 38 to 74. So we want to try and scale this axis so that it is as appropriate as possible. So if I need to go to 74, from 38 to 74, then I should, let's count by tens. Okay, so 0, then I will go 3 bars, 10, 3 bars, 20, 3 bars, 30, 3 bars, 40, 3 bars, 50, 3 bars, 60, 3 bars, 70, 3 bars, 80. Just a rough, you didn't have to be 10, 20, 30, 40, so we're counting by tens. The y-axis goes from, well, of course, 0, but it goes to 84. So we're going to go this one to 90. So I'll go 3 bars, 10, 20, 30, 40, 50, 60, 70, 80, and the last one would be 90. So we're going to go 10 up to 90. So our scatter plot says to plot these as pairs. So 38, 41, I'd go to 10, 20, 38 to 41. 38, 41, we would say is this point right here. Then 56, 63, so 40, 50, 56, kind of right in the middle. Then I have 50, 63. Then I have 59 and 70, 40, 50, 59. Goes with 70. Then I have 64, 72, 40, 50, 64, 72. And then lastly, 74, 84. So 74, 84. All right, so we have a scatter plot with our 5 points on it. The last question on the first page says to describe the plot. Well, when you describe a plot, you want to think form, outliers, direction, and strength from our last video. The form, can you envision a line through this? Yes, so this is linear form. Outliers, if I look at a line, right? If you envision a line through these points, do you see any points far from the rest? No. So no outliers. Direction, do these numbers go up or down? They go positive. So positive direction. And then strength, do these look like you could easily make a line through them? So our choices again are strong, moderate, moderately weak, or weak. I would say this is strong. These 2 last words we will check with our new correlation value. Is it indeed positive and strong? So that was our first page. Being able to make a scatter plot, right? Label your axes, label the values, and then describe the scatter plot. Form outliers, direction, and strength. The next page is how we will calculate our correlation. So in order to calculate the correlation by hand, you still do need to use the calculator because we need things for the formula. So remember on our formula, so I'm going to keep the formula up on the page for you guys. I'm going to write it up just so we have it stored away for us in a second. But before we get into it, we need the mean and standard deviation for our x and our y. We will use the calculator. So have out your calculators. I want to show you how this works. So here's my calculator. Let me tell you how I'm going to work this. I'm going to press Stat and Edit. This is where we've put data in before. Remember, remember, if you have data in a list, like I have these in list 3, I just typed them in, and you don't want them there, to delete a list, you highlight the name of the list, L3 is in black, you hit clear and the down arrow, and it clears the list. So what I've done is, I took the X variables and I put them in list 1, and I typed the Y in list 2. So list 1, list 2, X and Y. Now, if you think, what did I do last time? I did stat, calc, and I did one variable stats. Well, since we have 2 variables now, I will do 2 variable stats. List 1 and list 2, and I will calculate some important numbers. This will give me my mean of the x's, my standard deviation of the x's, my mean of the y's, and my scroll down standard deviation of the y's. Again, stat, calc, stat, edit, and I put in my numbers, which were 38, 56, 59, 64, and 74. And then my y values of 41, 63, 70, 72, and 84. We did stat, we did calc. This is 2 variable stats. My x's are in list 1, my y's are in list 2. Oops. Look at this. I had frequency list 2. We want that to be empty. Clear that out. Nothing in frequency list ever. That was from a different class. Here we go. Now we get the right answers. The right answers, 58.2, 13.19. So what we need to do is take the important ones and bring them back. So our x bar is 58.2, 58.2. Our SX is our standard deviation, 13.2. Our Y bar is 66. And our SY is 15.9. I rounded it. Okay, so that's all we need on the calculator. We can go back to this, and now it's time to do our correlation. So first, our mean of the x's was 58.2, and the standard deviation was 13.2. Our mean of the y's was 66, and our standard deviation of the y's was 15.9. What does the formula for correlation say to do? It says, for each of the x values, to calculate x minus x bar. Well, what does it mean, x? What is x? X is going to be each of the original data points. So our first x value was 38. 38 minus the mean, 58.2, our x mean, over standard deviation of the x's. These go together, and then these go together. 13.2. Then it says the formula. Now the formula said 1 over n minus 1 times x minus x bar over sx times y minus y bar over sy. and sum of all of those up. So I have x minus x bar over sx. My first y was 41. 41 minus y bar is 66 over sy of 15.9. You multiply those together, and that will be our first score in the what we need to add up. I'm not going to write all this live, so I pre-wrote it so everyone can see it and I don't have to take all of your time writing this out live. So let me pull up here in preview. Here we go. So to recap, I found the same x bar, sx, y bar, sy. There were 5 data points, so my n is equal to 5. What am I doing here? This is the brunt of the work. Each point, 38, 41, you have to subtract the means and divide by the standard deviation. So look at this first column right here. All of these are minus 58.2 divided by 13.2 because these are the 5 x values. Here are the 5 y values, the original 5 y's. So I subtracted the y mean and the y standard deviation. Then we get to these bigger numbers. The ones, look at my cursor, these bigger numbers. This is found by doing this times this. I got 2.4. This times this, 0.031. The formula, this little e, this weird looking e, says to sum these 1, 2, 3, 4, 5 numbers. If I add these numbers, it's 3.966. And then the last thing to do in the formula is to divide by n minus 1. So 5 sets of points. There were 5 points on our scatter plot. So divide it by n minus 1 is dividing it by 4. R equals 0.9915 for this data. So again, as you look at your notes, this is how you would calculate correlation by hand. You have to find x bar, y bar, sx, sy on the calculator. Then use the formula of point minus mean over standard deviation for the x's and the y's. Get all 5 of these numbers for the 5 data points. Add them. The sigma means add. It means, this is Greek letter sigma. Add and divide by points minus 1, which is 5 minus 1, or 4. This is indeed our correlation. What does correlation mean in this data? 0.99 is almost a perfect 1. So this data is almost perfectly linear. That means the strength is strong. This is strong correlation. It is also a positive number, so it's positive and strong. But this is how you calculate our correlation by hand. Okay, this is how you calculate correlation by hand. The good news is you will only be asked to do this basically one more time, and then we will be done doing calculation of correlation by hand, and we will do it on the calculator. So back to our slides. So that was our worksheet. Okay. What you're going to do right now is you are going to do page 162, numbers 13 and 14 as classwork. But before we get into the classwork, which you're going to do correlation by hand just once, you're going to go on and take a quick video check quiz. All right, I'll see you for 4.2.